So in this video, I will explain on how to find the inverse. Okay, inverse of the matrix. Okay, so they have two approach. Okay, to approach for two different sizes. The first one is for 2 by 2 size, and this one for 3 by 3 and above lah. Okay, 3 by 3 and above means 4 by 4, 5 by 5, and so on. Okay, so two different way. Okay, for 2 by 2 is obviously it's more simple compared to this 3 by 3 and above. Okay, so I show you for 2 by 2 first. What's the steps inside? What's the steps that you need to find? Okay, so the first step for 2 by 2, what we do is you need to interchange. Okay, interchange A and D. A and D. Okay, what's mean A and D? Okay, I write first what's the matrix for 2 by 2. Let's say you have A, B, C, D. Okay, let's say this is the general matrix that you have for 2 by 2, A, B, C, D. So what's mean by interchange A and D means that you swap. Okay, instead of, you swap lah between these two. Maksudnya if here is A, right now here is A and here is D. So after you swap, it become here is D and here is A. Okay, maksudnya you akan dapat matrix macam ni. D, B, C, D lah. Okay. Alright, so then step number 2, you change the sign of B and C. Okay, maksudnya for example, if here B, C positive value, so it will change become negative. That's here kalau dia positif lah, but here if here is negative, so you become positif. Maksudnya you just interchange lah. Kalau dia negatif situ, dia akan jadi positif kat sini. Okay, alright. So let's say lah, we assume that here is positive B and C. So means that the new one you will have, oh sorry saya salah ni A kan. Okay, DA, this one is negative B and negative C. Okay, we consider this is positive. Okay, so we will get this value, these matrices. So now for step number 3 is to find the determinant of A. Okay, this is a matrix A just now. So find out the determinant A. Okay, the old A, not the new one, the old one. Okay, the old A. So the determinant for 2 by 2 is simple, right? AD minus BC. Okay. Okay, therefore your answer for A inverse for 2 by 2 is 1 over determinant. Okay, you will get the value here later on, and then multiply with your matrix, the new one, the new matrix, D negative B negative C A. Okay, so this is the general one lah. Okay, if you can't see clearly, okay, I erase this one first. Okay, if you can see clearly, I give you the example on we put a number lah, kita put number. For example, you have a matrix A equal to apa nak bagi ni? Okay, for example 2, 1, 3, 4. Okay, for example, alright. So this is your matrix A. So the first steps that you need to do is interchange A and D. So it become 4, 2, 1, 3. Okay, after that change the sign. Okay, the sign now here is positive, right? Positive, so means that kat sini akan jadi negatif lah. Okay, negatif lah. Okay, kalau sini negatif, maksudnya kat sini akan jadi positif. Tu je, terbalikkan. Okay, alright. So for step number 3, you need to find the inverse. The determinant of A. Okay, the old A. Jangan salah. Ni the new one. Okay, kita tengok. We refer to the original one. So 4 times 2, 8 minus 3, so we have 5. Therefore, the inverse of this matrix A is 1 over 5 times with this matrix. Okay, you can simplify or you can just leave it like this. So kalau simplify, you should get 4 over 5, negative 1 over 5, negative 3 over 5, and 2 over 5. So this is how we calculate inverse for 2 by 2. Okay, it's just have 3 steps. Okay, so now I will show you how to calculate inverse for matrix 3 by 3. Okay, for the matrix. Okay, before that, you need to know the steps. Okay, for 3 by 3, okay, this is for 3 by 3 matrix. So the first step is you need to calculate or you need to find each cofactor. Each cofactor maksudnya you need to calculate all cofactor that contains in that matrix lah. All each of it, maksudnya each of it, semua. Okay. Why just cofactor? You need to calculate minor or not? Yeah, you still need to calculate minor because of what? You need to remember to get cofactor, you need to calculate minor first. Okay, even though step ni terus direct to cofactor, tapi bukan bermaksud you tak perlu calculate minor. You need to calculate minor. Tak, memang tak boleh lari. I mean to get the cofactor, you need to calculate minor. Okay, so after you calculate the cofactor, what we do next is we find the adjoint matrix. Okay, so what's the adjoint matrix? I know most of you will what's the adjoint matrix? Okay, what's the adjoint matrix? Okay, we denote is adjoint A. Okay, adjoint matrix actually is a matrix of the cofactor transpose. That's why if you still remember for the previous video, I said that if the question asks you to find all cofactor, so the final answer I suggest you, I prefer you to write in terms of the matrix. This is why. This is the reason why. Because matrix of cofactor, okay, Cij, C means cofactor. So the matrix of cofactor, the transpose of the matrix of cofactor is the adjoint A. You need to find the adjoint A to get the inverse for 3x3 matrix and above. So to get the adjoint A, you need to find the cofactor first and then transpose. Okay. Alright. So then for the so they have two steps here. So the last one is the step number 3. You need to determine the the determinant of A. Okay, sama jugalah macam tadi pun untuk 2x2 you still need to calculate the determinant of A. So the last one, the answer that you should get is 1 over determinant, but now you need to multiply with the adjoint A matrix. Okay, so I repeat the first step for the 3x3. Okay, totally different totally different for 2x2 and also 3x3 and above. For 3x3 and above, you need to start first with the cofactor. Okay, after that you need to find the adjoint A. So what's the adjoint A? What is a matrix adjoint? Matrix adjoint is a transpose. Okay, cofactor transpose. Maksudnya matrix of cofactor that you transpose it. Okay, you can transposekan the matrix cofactor that you get from step 1. Okay, after that for step 3 or the last step is you need to find the determinant of A. Then you just substitute into the formula. So basically for 2x2 and 3x3, basically dia punya formula quite similar. Cuma kat sini lah dia punya beza kat sini. Okay, and also how to reach or how to get adjoint A also different lah compared to 2x2. Okay, so now I show you through example. I give you one example. Okay, let's say your matrix A is 2, 0, 1, 3, -4, -1, -4, 2, 5. Okay, so the question asks you to find the inverse. Short, simple and short question, but they have 3 steps that you need to do. Okay, so the first step is you need to find all the cofactors. All. So all means M1. Okay, to get your cofactor, you need to find M minor first. So you need to calculate M11, M12, M13, M21, M22, M23, M31, M32, M33. Okay, alright. So what I mentioned before, 1, 1, 1, 2, and so on is a number of row and also number of column. So what we need to do for the first one, M11, you need to close the row number 1 and also column number 1. Okay, row number 1 and also column number 1. So you left with -4, 2, -1, 5. Okay, so for M12, close row number 1, column number 2, 0, 2, 1, 5, For M13, row 1, column 3, 0, -4, 1, -1. Is it betul? Betul tak? 1, 3. Okay, so then for M21, row number 2, column number 1, so 3, -4, -1, 5. Okay, for M22, 2, 1, -4, 5. For M32, okay, M23, 2, 3, 1, -1. Okay, and then M31, row 3, column 1, 3, -4, 4, 2. M32, 2, 0, -4, 2. Okay, M33, 2, 0, 3, -4. Okay, so okay, calculate lah each of it. Okay, calculate each of it. Okay, after you get this value, okay, then don't forget to find the C lah. Okay, C11, C12, C13, C21, C22, C23, C31, C32 and C33. Okay, calculate. Okay, nanti calculate ni lah. Okay, so actually, okay, so your answer for C, okay, I give you the final answer lah for C. So the C you should get -18, 2 and also 4. Okay, and then -11, 14 and 5, and then -10, -4 and also -8. So this is matrix C. Okay, this is matrix C. So you settle on step number 1. So the next step is to find the cofactor transpose. Okay, I mean for step number 2 is find adjoint lah. Adjoint A is equal to C transpose. So just now you get C, right? You get C. So for the next step, you just transpose your C. So you should get -18, -11, -10. Oh, saya rasa saya terbalik. Okay, sekejap. Betul tak ni? Matrix C, you should get C11, C12. Sorry, C12 is here, right? Okay, so saya terbalik lah. Ni dah transpose kan? Okay, sorry. Okay, C should get -18. Okay, C12, you should get 2. This one is 4. Okay, then here is -11, 14 and 5, -10, -4 and -8. Okay, sorry, my bad. Okay, saya dah transpose siap. Okay, so sekarang bila kita transposekan dia akan jadi, okay, sorry alright, so dia akan jadi -18 to 4, -11, 14 and 5, -10, -4 and also -8. This one the correct one lah. -18, -11, -10, 2, 14, -4, 4, 5, -8. So this is your adjoint. Okay, after you get your adjoint, step number 3 is to find the determinant of A. So you can choose either one lah, any row, any column. So like I said before, it's more easier for you to choose the row that contains 0. Okay, so either you choose column 1 or row 3. Sorry, row 3 pula. Row 2, sorry, column 1 and row 2. So you should get your determinant is -46. Okay, I don't want to show it again here, but the answer that you should get is -46. Okay, so lastly, the answer here, okay, the answer here is 1/-46 times with this -18, -11, -10, 2, 14, -4, 4, 5, -8. So you can simplify lah. Simplify is better for you to simplify lah. So -18 divided by -46, you have 9/23, and then negative, so 11/46, and then here is 5/23, negative 1 over 23, negative 7 over 23, 2 over 23, negative 2 over 23, negative 5 over 46, and the last one 4 over 23. Okay, alright, so this is how we calculate the inverse. Okay, so basically you have finished chapter 1, matrices.